OK, so now let's get to the more interesting part of what we can do with associations. And this concerns the motivation of what if you want to express a relationship that's actually many-to-many? Because if the scenario now is we've already done movie has many reviews, but now let's introduce the concept of a moviegoer, which is someone who writes the reviews. So clearly a moviegoer can have many reviews, but a movie can also have many reviews. So there's relationships being implied here that are really many-to-many, right? If you think about the relationship between if a moviegoer has many reviews and a movie also has many reviews, then in some sense the relationships between movies and reviews is now many-to-many, right? There can be many reviews for the same movie. Sorry, the relationship between moviegoers and movies is many-to-many. Is that right? Yeah, that's right. OK, so and of course we can't just use has many and belongs to for this because there's no way that there's no place in the tables where we can encode both of the relationships. So the solution, which is actually similar to if you've come from other programming frameworks for SAS, similar to join tables but different. And stay with me because they're different in a pretty important way. Really what you do is you create a whole new model whose job it is to model the relationship. And this concept actually turns out to be very, very useful. Very often, when you find yourself in a situation where you're saying, I've got x's and y's, and there's a many-to-many relationship between the x's and the y's, and how would I model that? In many cases, what it turns out you really want is a separate model that models the relationship. You can think of friendship on social networks as being an example of this, right? The relationship among friends, when you model, there's an entity that means the concept of a user, but you really also want a separate entity that is the concept of a friendship because you want to know between which two users the friendship exists, but you might also want to track things like when was that friendship initiated, are there tags or shared items that are shared just between that pair of users. So often what you find is you really want a separate model that captures the idea of two instances of things being connected to each other. So in this case, this is how we can use the same tricks we already know to do a many-to-many association. We can say that a review, which is just an integer for the number of potatoes, as you recall, is now going to have two different foreign keys. Besides the movie ID key, which it already had, which identifies what movie it belongs to, there's now a separate moviegoer ID, which is a foreign key back to another table, a table with moviegoers, like users, one per row. So now a review has a relationship to both of these things. And now we could say moviegoer has many reviews, a movie also has many reviews, and a review belongs to each of the two sides, right? Which intuitively this makes sense. You can, for a given review, two equally logical questions are what movie does it go with and who wrote it, right? Or what moviegoer does it belong to? So the question is, given that the premise here is that we're trying to establish many-to-many relationships between movies and moviegoers, how do you use this intermediate association to say, for example, all the movies reviewed by some person? Well, we can now say that a moviegoer has many movies through reviews. Right? This is the concept of a through association. So what it's really saying is that, yeah, there's a relationship between things on this side and things on this side. But to traverse that association, you've got to go through an intermediate model which models the individual relationships. So for a given moviegoer, I could find all of the reviews whose moviegoer ID matches that reviewer. And for each one of those reviews, I can then ask which movie does it belong to. And by doing that, I've basically done the query of what are all the movies that that person has reviewed. Similarly, I can say that a movie has many reviews, and it also has many moviegoers, in other words, people who reviewed it, through the reviewers association. So I can also traverse it in the other direction, right? And what this logically means is, given a movie, I can figure out what all are the set of reviews that belong to it. So in the reviews table, for which ones is it the case that movie ID matches the primary key of that movie. And then for each of those reviews, I can grab its moviegoer ID and look up who wrote it. So I can traverse the association in both directions, right? For a moviegoer, what are all the movies they reviewed? And for a movie, who are all the moviegoers that reviewed it? And again, review is in the middle, right? It kind of belongs to both of these things at the same time. And there's no conflict in belonging to more than one thing, because remember that if belonging to moviegoer and belonging to movie implies two separate foreign keys, right? Remember the mnemonic that, which table has the foreign key in it? It's the table of the owned model. So if the review is owned by two different kinds of things, that just means that that table has to have two different foreign keys in it, representing the ownership through each one of the other models. So once we've set that up, now you can say things like movies that were reviewed by a particular user. Or for a given movie, as I said, we can show who all rated it. And I can also do my potato scores for all the R-rated movies, right? I can look for, within all of my reviews, right? Just remember that all of these active record queries, basically, return another object that can also handle the same kind of queries. So I can get all the reviews associated with a particular user and treat that as an enumerable. And how is this actually working? I mean, compared to the model we saw before, well, this is actually a really simple extension, right? When I say user.movies, what's actually going on is I'm constructing a query that looks something like this. Remember before, when we talked about Cartesian products, we said we're going to take two tables. We're going to match up every row of one with every possible row of the other. So the total number of rows is the product of the number of rows in the two tables. And then we're going to filter out only the ones where there's an equivalence condition between a particular foreign key and a particular primary key. Well, we're going to extend the same thing, only now we're going to do a three-way join, which sounds a little kinky. But we're going to take three tables, and for each row of each table, we're going to join it with every possible row in the second table, and in turn with every possible row in the third table. But then we're going to keep only the rows for which two equivalence conditions are true, right? One of them is that the moviegoer ID matches the primary ID of a moviegoer, and the other one is that the movie ID matches the primary key of a movie. So if I do this multiple-way join query, what I'm going to be left with is triples of moviegoer, review, and movie that all participate in the association, right? It's a review that is owned by each one of the two sides. So with that in mind, which of the following is not a correct way of saving a new association, given that M is an existing movie? And as a hint for this question, I would say, remember what foreign keys have to go where and how they might get there when you're trying to create a new instance of an object that participates in an association. So we could say review create. We could pass a specific movie ID as the foreign key, and potatoes, that's just the actual review content. Or I could start with the existing reviews object and build a new review on top of it and then save it. Or I could add on to the existing reviews object a new review and then save that. Or maybe all three of these are valid. So take a look at that for a moment, and we will talk about the answer.